we are going to discuss the important part of organic chemistry, that is mechanism of organic reactions. We have studied many reactions in first year. In second year we are going to study many reactions. But let me see first what are the mechanisms are going to take place and how they are going to take place. That I want to explain today. Very important bit of organic chemistry. Okay, have you observed that there are different types of reaction? Okay, we'll move to one by one. Like substitution. Like substitution reactions. Students, have you observed that substitution reaction in first year we have studied electrophilic and as well as free radical. Electrophilic, free radical, but in second year we are having nucleophilic. It means that free radicals, substitution reaction, then nucleophilic substitution reaction, then electrophilic substitution reaction. That means that there are three types of substitution reaction. It may take place through free radical, it may take place by nucleophile, it may be takes place by electrophile. Okay, so let us move to first one. Free radical substitution reaction mechanism. Free radical substitution reaction mechanism. Children, have you remembered that in case of this one free radical substitution reaction, we said that free radicals are going to be generated when halogen undergoes homolytic fission. Halide undergoes homolytic fission in presence of diffuse sunlight or UV light. They are going to generate free radical. I did not repeat once again what is free radical. In previous video, we have discussed all these. Free radicals. Now the question arises that whether all halogen will undergo same? No. Order of halogenation to open chain hydrocarbon, that is saturated hydrocarbon, is F2 greater than Cl2 than Br2 than I2. But F2 is violent reaction and exothermic reaction. Very violent reaction, enormous amount of heat energy is released. That's why we are not going to prefer. Why not I2? Okay, I2 will take place always in presence of HiO3, hydroiodic acid, as a catalyst. Okay, then bromination is very slow reaction, very slow. Iodination takes place as a reversible as well as in presence of HiO3. The most preferable is chlorination. That's why in our syllabus they have mentioned related with chlorination. And we know very well that systematic study of a reaction step by step. How many steps are there? 3 steps. Chain initiation, chain propagation and chain termination. In chain initiation, radicals are generated. Then in chain propagation, different steps are going to involve till they are going to get, what, tell me, all reactive species. That is respectively. In the last one, all reactive species are combined to form a neutral molecules. Let us move to the first mechanism, that is free radical substitution, that is halogenation of methane. Shall we go to the first one? Yes, right. Halogenation of methane. That is chlorination of methane. Methane undergoes chlorination to replace 1 by 1 hydrogen atom of methane by halide group. To replace 1 by 1 hydrogen atom by halide group. That is chlorination. Chlorination of methane. Methane undergoes chlorination to get methyl chloride, dichloromethane, trichloromethane, and finally what? Carbon tetrachloride. Final product is what? CCl4 plus HCl. Okay, plus HCl. Now we'll see the mechanism. How does we are going to get the different products? different products. Okay, so let us move to the chain initiation. In the step 1, chain initiation. What we have observed, have you remembered? That chlorine molecule undergoes homolytic fission in presence of diffuse sunlight or the UV light to get a 2 chlorine free radical. 2 chlorine free radicals are going to be generated. Because of chlorine free radical only, reaction are going to continue. In the second step, what it is, tell me? Chain propagation. Propagate means what? It is going to be elongated. It is going to be continued. How does it is going to take place? When methane undergoes chlorination. Chlorination by chlorine free radical, they will produce methyl free radical and HCl. What tell me? Methyl free radical. How long free radicals are there? So long reaction are going to take place. Because these are reactive species. Methyl free radical with chlorine molecule produces methyl chloride and chlorine free radical. We got first substituted product as methyl free radical. Then methyl chloride with chlorine free radical will produce methylene free radical, methylene chloride free radical along with HCl. Along with what, tell me? HCl. Then methylene free radical along with chlorine molecule will produce dichloromethane. Dichloromethane with chlorine free radical. Now we got second product. Okay. Let us move to the third one. Methylene chloride with chlorine free radical produces dichlorosubstituted methane free radical along with HCl. All these free radicals are having very less lifetime. Free radicals are going to be generated. Then CHCl2 with chlorine free radical produces third product as chloroform along with chlorine free radical. Where I am underlining, just to observe, 1 hydrogen atom of methane replaced by Cl, 2 hydrogen atom, 3 hydrogen atom. And the last one, we can say that when chloroform, CHCl3 is what? Chloroform. With chlorine free radical will form trichloromethyl free radical along with HCl. Finally, are you getting my point? Trichloromethyl free radical with chlorine molecule will form carbon tetrachloride and chlorine free radical. Just to observe over here, first product we got it as methyl chloride, dichloromethane, trichloromethane, and the last one carbon tetrachloride. All these are what? Chain propagation. One by one. Every reaction they are involving one free radical. Just to observe all, I am repeating once, I am mentioning once again, I am going to point out once again how they are going to get a free radical. So it means that never ending reaction. The last one is termination. Here itself at one side I will write, it will be easy for you to conveniently to recall all. The third is, what, tell me? Chain termination. Chain what? Termination. In case of chain termination, all free radicals are combining to form neutral molecule because reaction has to stop, terminate, to stop. So here chlorine free radical with chlorine free radical form neutral molecule. Methyl free radical with chlorine free radical will produce methyl chloride. Methyl free radical with methyl free radical, they will produce C2H6. C2H6. Children, have you solved the previous question paper? In one of the competitive exam paper, they have asked this question. That other than all substituted methane, which is the hydrocarbon obtained during chlorination of methane? Because usually children will think of one carbon atom. But we are getting the one of the product with 2 carbon atom. This is one of the competitive exam question paper. Okay, this is all about the substitution. Substitution by what? Tell me. Free radical. Now you may think that, okay, let it be. Chlorination can take place. If we want to get a brominated product, what to do? Usually fluorination are very exothermic, violent reaction we are not going to discuss. Bromination may be slow step, but sometimes we need brominated product. You may think that how does the bromination can take place? Yes, bromination also possible, but the reagent is different. Mechanism will not involve as what we have discussed now. Okay, so let us move to the, this is actually substitution will take place only at allylic carbon atom. That's why it is called as bromination of allylic hydrocarbon. Only for allylic, bromination of allylic. In previous video, as I said, allylic, bromination of allylic hydrocarbon. Already I said to you, carbon-carbon single bond, alternate single and double, where substituent functional group linked to the doubly bonded carbon atom which is next to single bonded carbon atom. CH2 double bond CH3. What it is tell me? Prop 1 when it undergoes substitution with NBS, N-bromosuccinamide. What it is tell me? N-bromosuccinamide. Where allylic carbon atom will undergo substitution reaction. In presence of carbon tetrachloride will produce CH2 double bond CH dominal, right? CH2Br. Many examples are there in the second PUC related with this. Those who are in the second year, they have not given this concept in the text, but they have mentioned many of the example in second year. That is cyclohexene with NBS. NBS, what it will produce. They have asked many of the question in NCERT book. Ethyl benzene, when undergoes bromination with NBS, what will be the product? Let us see one by one product. As I said that all these are what? Allylic substitution reaction. That's why we will get the answer for this as substituted. Here we will get a Br. It may be possible that this Br may come to down also. Don't think that only this one, because both are allylic. I can write like this also. Both are same product. Same way with this, which is allylic, tell me now. This is carbon-carbon double bond. This carbon atom will be allylic. Many examples are there in NCERT book. Just you turn the pages and you will come to know that what are the product. Because many time in exam, competitive exam, they have asked like this question related with N-bromosuccinamide. Finish? So let us move to next one. This is all about the free radical substitution. Now we will move to electrophilic substitution reactions. Right, second one. Electrophilic substitution reaction. What tell me? Electrophilic substitution reaction where electrophiles are maybe neutral molecule which are deficient in electron. They may be positively charged species. They are called as what, tell me? Electrophiles. Second one is what? Electrophilic substitution reaction. Electrophilic substitution reactions. I will not repeat once again. These are deficient means they are going to attack on pi electron cloud. Here different examples are there. I'll write one by one over here only. Mechanism will see it once. First one is halogenation. Halogenation. The free radical generated is what? Halogen carrying positive charge. Second one is what? Nitration. Electrophile generated is what, tell me? Nitronium ion, NO2 plus. Third is sulfonation. Third is what? sulfonation. Electrophile generated is water, SO3. Next, Friedel-Crafts reaction. Fourth one, Friedel-Crafts reaction. In case of Friedel-Crafts reaction, again alkylation and what is one more? Acylation. For alkylation, alkylium ions are generated. For acylation, acylium ions are generated. Therefore, we can say that still we need to discuss all these mechanisms. Halogenation, we can say that halogen ion. Before going to all these electrophiles, because in all the 4 cases, not 4 we can say, in the 5 cases, we are going to generate electrophile in step 1. Means electrophile are generated. For example, if electrophile is generated as X plus, and we know very well that electrophile are abbreviated as E plus. How they are going to attack on benzene? That we'll see. This is benzene molecule and this is electrophile. Maybe any one from all these. Have you observed that? Last year CET paper they have asked the question. Which is the electrophile during sulfonation of benzene? Alone electrophile without positive charge is sulfonation, that is SO3. In case of attack of electrophile on benzene, as the movement of the pi electron takes place to the other carbon atom, why it is so? On what basis? Because electrophile attacks on benzene. When electrophile approaches to benzene, pi electron cloud has to be delocalized in such a way that they are going to generate carbocation H. Because every carbon atom containing one this one, hydrogen. Carbocations are generated. This carbocation are stabilized by neighboring pi electron. What they'll get, show me? What they'll get? Here there is a formation of carbocation, double bond will come. Again H and E. E is representing what? Electrophile. Stabilized by neighboring. What will get, tell me? Delocalization of pi electrons. H and E. This electrophile may be from this, maybe from this, maybe. Any of the electrophile. This electrophile, it may be, we'll write one example, chloronium ion, maybe nitronium ion, maybe SO3 molecule, because O is carrying slight negative charge, S is carrying slight positive charge. Maybe alkylium ion or maybe acylium ion. Acylium ion. This is in the second step. The last step is to make it stable by the loss of proton. Because as we know very well that along with electrophile, one more negatively charged species are going to form over there. Therefore, we will write it as plus H and E. Protons are lost. It means that this sigma electron can be shifted to neighboring carbon. It will produce what, tell me? It will produce benzene substituted with electrophile. And H plus can combine with another reagent. We can say that in a simple way, very easy to remember, where we need to concentrate for the need, that which is the electrophile and in what way they are going to disperse the electron cloud. This is all about the electrophilic substitution reaction. And always remember that in case of halogenation, like chlorination, in case of chlorination of benzene, we are going to use any Lewis acid as a halogen carrier. In previous videos, already I said to you all these. Same way, in case of nitration, we are going to use concentrated nitric acid and sulfuric acid, that is nitrating mixture. Whereas in case of sulfonation, by heating with concentrated sulfuric acid. All those shall be right once again. Okay. Because based upon nitration and sulfonation, before last year, question papers, they have asked the question. What are those? That we'll see. It is when benzene undergoes chlorination in presence of halogen carrier as FeCl3. Instead of FeCl3, even you can use Fe also, Lewis acid, AlCl3, anything we can use, any Lewis acid. It will produce Cl along with HCl. Same way, benzene, by heating with concentrated nitric acid in presence of concentrated sulfuric acid, they will produce what, tell me? Nitrobenzene along with H2. Benzene undergoes sulfonation with concentrated sulfuric acid by heating at high temperature, that is around 150 degrees Celsius. They are going to produce benzene sulfonic acid along with H2. And the last one, Friedel-Crafts alkylation. With alkyl halide, let us take one example, methyl chloride, simple example. In presence of anhydrous aluminium chloride, they are going to produce toluene along with HCl. If it is a Friedel-Crafts acylation, benzene with acylation, same conditions are there as we are mentioning over here, but we will get the product as acetophenone along with acetic acid. In one of the paper, competitive exam paper, they have asked one question, simple question is very simple, that what is the role of concentrated nitric acid in nitration of benzene? Concentrated nitric acid in nitration of benzene act as a base. Try to understand, name is acid but the role is base, because when it generates NO2 plus as well as OH minus. As you have studied in the equilibrium topic, that is OH minus ion molecule producers, they are called as base. Finish? Shall I move to the next? Last one is nucleophilic substitution reaction. Last one is what? Nucleophilic substitution reaction. Nucleophilic substitution reaction, actually those who have written second PC exam, they are having clear picture for nucleophilic substitution reaction. Nucleophilic, what tell me? Nucleophilic substitution. Substitution by what? Nucleophile. That means that nucleophilic substitution reaction. Two mechanisms are there in our second year example. One is a unimolecular nucleophilic substitution reaction and another one is bimolecular nucleophilic substitution reaction. Okay, those who have written the first year exam, then they will go to the second PUC, they will see in detail. Let me explain here. SN1 mechanism, unimolecular nucleophilic substitution reaction, because order of a reaction is 1. Order of a reaction is 1. It is a unimolecular. That means that rate of a reaction depends upon only the concentration of one molecule. Order of reactivity is tertiary, greater than secondary than primary. In previous video, as I said, tertiary carbocations are more stable. Therefore, SN1 mechanism takes place through carbocation, through the formation of planar molecule or a carbocation. And one thing, when it is a planar, nucleophile can attack. If we are going to take Rx, where R is a positive charge, X is a negative charge, by the attack of nucleophile, they are going to produce ROH. It means that R plus is planar in nature. Nucleophile can attack either from front side or from back side. That's why we'll say that SN1 mechanism is racemization. What a racemization. They will involve or racemization. They are going to produce dextrorotatory and levorotatory both in this one. The resultant mixture will be optically inactive, but individual isomer will be optically active. Same with SN2 mechanism. Bimolecular means what? Bimolecular means what? Two molecules means alkyl halide and nucleophile both will be responsible. Bimolecular nucleophilic substitution reaction. Bimolecular nucleophilic substitution reaction. Order of a reaction is 2. Order of reactivity primary, secondary and tertiary. Always intermediate will be as a transition state where incoming and outgoing nucleophile both will be present. Incoming and outgoing nucleophile both will be present. That's why we'll say that always they'll produce what? Inversion. Inversion. Reverse. Inversion. If the given alkyl halide is dextrorotatory, final alcohol will be levorotatory. Rx plus OH minus will produce OH and R. If this is positive, this will be negative. Remaining type we'll see in the next videos.